Hello everyone, my name is Wobuchi Nazabola Tito, representing Chukwuemeka Odumegwu Ojukwu University, Nigeria, on the topic Design and Incorporation of Infrared Thermometer and a Nose Mask on a Goggle. These are the highlights to the presentation. Background to the study/problem statement, concepts, objectives of the study, significance, design consideration, theories, material selection, methodology, target market, marketing plan/strategy, budget, work schedule, technical specifications and conclusion. Background to the study. COVID-19 is a novel viral disease which was discovered in Wuhan, China on the 17th of November 2019. Odometer's info on COVID-19 statistics as at 15th April 2021 show that there are about 139 million total number of confirmed cases, 2.9 total number of deaths, and about 114 million total number of recoveries across the globe. Coming down to Nigeria, these are the statistics that shows total number of confirmed cases, total number of discharged patients, and total number of deaths. In a bid to fight the pandemic, so many professions came together to show their expertise, of which engineering is one of the leads. Statistics shows a greater percentage of devices that have been designed and produced are mainly for prevention. Despite how much attention has been given to its prevention, the virus is still spreading. This is because there are not enough devices for its detection and even for treatment. World Health Organization gave a list of about 13 symptoms of COVID-19, of which fever is number 1 on their list. It is on this wise that this project came up with the aim of designing and incorporating an infrared thermometer and a nose mask on a goggle. This device will not just serve as a detective device but also a preventive device. Our concept. In order to avoid cognitive dissonance in our marketing process, we conducted a survey so as to show what our potential customers really want. This engineered our concept, hence now design. We concluded and made the sensor and the program circuitry detachable so that anyone who wants to go for the full device due to his or her eye problem, example someone like me, or any other confidential reasons, can just buy the sensor and clip it on his or her eyeglass. This statistic shows who is wearing face masks. How do you feel about wearing face masks according to ipsos.com, and people who wear face masks outside their homes according to statistical.com. Our objectives are to carry out a field survey on the needs and wants of people as regards to goggle and nose masks, to prepare a 3D CAD geometric model for the nose masks, the goggle and the casing for the program circuitry using SolidWorks CAD software, to design the program circuitry using Arduino Mini Pro. Significance. The device serves as a dual purpose of detection and prevention. The device is cost-friendly and can be afforded by an average citizen. The device will not only be used by security men in shopping malls and banks, but can be used by anyone, anywhere. The research work will serve as a guide and reference for upcoming academic researchers to build on. Our design considerations are lightweight. We plan on keeping our device as light as possible. Cost effectiveness. We plan on making our device as cheap as possible for an average citizen to purchase. KISS principle, keep it so simple. We know that even though the information about COVID-19 has spread far and wide, we also know that even to wear the normal face mask, some people don't know how to wear the normal face mask properly, and that's why we try to keep our device as simple as possible in order for the person using the device to easily operate it. Ease of manufacturability and comfortability. Some of the theories backing our design include fundamentals of light, electromagnetic radiation, and Boyle's law. Material selection for the nose marks. World Health Organization recommended the use of fabric in producing nose and mouth marks, so we use a fabric in designing the front parts of our nose marks. We looked at the properties of some fabrics like cotton, nylon, silk, wool, and linen. Dr. Gustavo Fer, a pulmonologist and president of Intensive Care Expert Health Network, as reported by Homan 2020, suggested cotton as the best fabric to be used in the production of nose and mouth masks due to its unique properties. So we made use of cotton in our design. Cottons are highly durable, soft, strong, dye-absorbent, comfortable, and can stand up against abrasion wear and high temperature. They are known as breathable fibers and natural hollow fibers. The porosity of cotton we used is 50 nanometer. Hubble 2020 noted that coronavirus is 100 nanometer in diameter and carbon dioxide molecule is 0.33 nanometer diameter. For the body of the nose masks, we made use of plastic. We looked at the properties of some plastics as listed below: polycarbonate, polyethylene, and polypropylene. After considering the above, we made use of polyethylene due to its unique properties. Below is a table containing the material properties of polyethylene. We made use of polycarbonate plastic for the screen of the goggle. Its special features that influenced our choice include strength, stiffness, hardness, toughness, transparency, and impact resistance. It is as clear as glass and 250 times stronger than glass. Benefits of polycarbonate plastics include light transmission. It offers light transmission properties that are comparable to glass, giving it an advantage over glass. It is significantly lighter and more durable than glass. It is easy to manufacture, it is readily available, and it has a good thermal structure. We made use of polyethylene plastic for the handle of the goggle. Special features of polyethylene include they have low coefficient of friction, excellent chemical resistance, good impact resistance, good fatigue and wear resistance, and zero water absorption. They are stable in cryogenic environments and are economical. For the nuts and bolts used on goggle, we made use of M0.5 nuts and bolts. The device works on the principle of electromagnetic radiation. The infrared thermometer has a sensor known as thermopile. The sensor absorbs the thermal radiation from the body and converts it to an electrical signal. This readable signal is being sent to the microcontroller known as Arduino Pro Mini. The signal, after being interpreted by the microcontroller, is sent to the liquid crystal display, which displays the temperature of the body to the user. The average temperature of a human body is 36 degrees Celsius. Anything above 36 degrees Celsius is considered as a fever. The liquid crystal display was designed to be adjustable to the taste of the user. The circuitry was also programmed to send a signal to the vibration motor and a beep to the buzzer if the temperature detected was above normal. The vibration motor and the buzzer will go a long way to easily alert the user of any potential danger, since most users may not be careful enough to monitor the readings on the liquid crystal display. These are the Arduino codes we used for our device. Our target market. Our first target markets are security men in banks and shopping malls who we expect to purchase the full device. Our second target market is the general public who we expect to make their choice of either purchasing the full device or purchasing the detachable sensor and clip it on their own eyeglass. We shall employ the 7 P's mix as our strategy, which include price, product, promotion, process, place, physical environments, and of course the people. These are our technical specifications. This is our 3D card model. This is our assembly animation. This is our budget estimate. For the Google screen, which we are using polycarbonate, our estimated price is £1.14. For the goggle body and the nuts and bolts, we are expected to use £1.14 and £0.02. For the mouth marks, we plan on using £1.14. The fabric £1.14. The Arduino Mini Pro is £3.81. The liquid crystal display is £1.14. The battery is £0.19. The button is £0.04. The connecting wires, the buzzer, and the vibrator motors is £0.38, £0.19 and £0.95. The subtotal for material cost is £13.88. For the supplies and consumables, we are considering soldering iron, electric gun and gum, and they cost £1.52, £0.95 respectively, which gives the subtotal of £5.33. Logistics, the transportation of materials and components is £1.98 and subtotal is £1.98. The grand total is £21.11. This is our work schedule. In conclusion, an infrared thermometer has been designed which makes use of a thermopile sensor with a maximum range of 1 meter. The 3D card models for the full device have been developed. However, it is recommended that a further research should be carried out for a sensor with a longer range. Please remember to stay safe and obey all COVID-19 guidelines. Thank you.